Hello. Today we will be exploring this integral right here, the integral of the square root of x to the 6th minus x to the 8th dx. So to solve this integral, first off what we're going to want to do is we're going to pull out an x to the 6th from each of these terms. Right, so then we have x to the 6th times 1 minus x squared. Then we could even pull that x to the 6th outside the square root. So we're left over with the integral of x cubed times the square root of 1 minus x squared dx. Now, we're going to want to let x equal to a sine theta, and then dx will equal to a cosine theta d theta, just like that. So now we could rewrite our equation here, right? So now it becomes the integral x cubed just becomes a sine theta cubed. The square root of 1 minus x squared. 1 we could rewrite as cosine squared plus sine squared, minus x becomes sine, so cosine squared plus sine squared minus sine squared, the sine squareds can cancel out, and we're left with a cosine squared term. Now that cosine squared term is in the square root, so that pulls out to just become cosine. So times cosine, times a cosine x times the a cosine theta, times the a cosine theta d theta that we get from converting from dx to d theta. So, that's what we have right now. Very lovely. From here, the next step is to right. From here, we're going to do a trig sub. So we're going to pull a sine squared out from a sine cubed, and then we're going to rewrite sine squared as 1 minus cosine squared. So we have the integral of 1 minus cosine squared. Then there's still a sine left over, so times sine. And then we could combine the cosines, so we have times cosine squared, all d theta. So now we have that. From there, what we're going to want to do is we're going to do a u substitution. So we're going to let u equal a cosine theta. From there, could plug back into what we have. We also need to figure out what du is, and du is equal to negative sine d theta. So, now that we know that du is equal to negative sine d theta, that sine left over outside from the previous term, we could use that as our, we need that, and that turns into the du. So then what we're left with is integral of negative my marker's really running out now. 1 minus u squared times u squared du. That splits apart to just be the integral of negative u squared plus u to the 4th du, which turns into negative u cubed over 3 plus u to the 5th over 5 du. Now we plug back in our u is equal to cosine theta. So plug that back in, and we have negative a cosine theta cubed over 3 plus a cosine theta to the 5th over 5 plus c. So that's what we have now. Now we need to convert it back into x from trigonometric functions. This is where it gets tricky. So to do this, we need to use a triangle. So we know that x over a is equal to sine theta. So, because that's what we defined as x in the beginning. So, we have this triangle. Sine is the opposite over the hypotenuse. So, if sine is equal to x over a, then we know that the hypotenuse will be a, and the opposite will be x. Now, from there, we know that cosine is going to be well, the third square here, we know that is going to be the square root of a squared minus x squared. So then we know that cosine theta is equal to square root of a squared minus x squared all over a, just like that. Now we plug that back into what we have, and we get that the integral of the square root of x to the 6th minus x to the 8th dx is equal to, this is going to be a long integral, it's equal to well, it's equal to negative square root of a squared minus x squared cubed over 3 plus the square root of a squared minus x squared to the power of 5 over 5 plus the constant c. And the a's in the front cancel out because you have an a in the denominator there, and you have an a cosine theta, so the a in the numerator also cancels out. So you end up with just the numerator term of this cosine. Yeah, and I believe that is it. Thank you very much. Have a fabulous day.